distance and displacement. In this video, we will see the differences between distance and displacement and how to calculate each in one dimension. Distance is defined as the measure of the length of the whole pathway followed by a moving object, regardless of in how many directions it moves, whether the pathway is straight or circular or curved. The distance is the length of the whole pathway followed by the moving object, and it is symbolized by S. Displacement is the direct or straight distance between the starting position and the ending position. It is affected by the direction the object moves. It is symbolized by delta x, where delta x is x final minus x initial. Delta x is the displacement measured in meters. X final is the final position or the ending position for the moving object in its trip, and x initial is the position from where it started moving. Distance is a scalar quantity, which means that it is always positive, it has a magnitude or a size, and it has no direction. While displacement is a vectoric quantity, which means that it might be positive or negative depending on the direction of motion and has a magnitude and a direction. Let's see this in a problem. Okay. On this line, we have first the direction, the positive direction is east to the right, east. Then this way will be west. The object moves from B to G to D to K. As we see, the object moved in different directions. How to find the distance and the displacement? The distance, which is S, it's equal to, we follow the steps. It moved from B to G, so I write BG, plus next step was from G to D, so I write GD, plus D to K, I write DK. BG means from this point to this point, so from -4 to 1, which is 5 meters. GD from 1 to 2, which is 3 meters, and DK from -2 to 5, which is 7 meters. So we replace BG is 5, GD is 3, DK is 7, and we get 15 meters. Or you can do it in a different way. We say BG, which is from this point, 1, you count, 2, 3, 4, 5. So BG is 5, we replace by 5. Then GD, 1, 2, 3. It is 3 meters. I replace by 3. Then DK, 1, 2, 3, 4, 5, 6, 7. I replaced by 7 meters, and I will get 15 meters for the distance. Now to find the displacement or delta x, we will find it in two different ways. The first way, delta x equals x final minus x initial, which satisfies with the definition of the displacement that says the displacement is a measure of the change in position for a moving object. So it's the difference between the final position and the initial position. Where did it start from? It started from B, so B is the initial position, and ended at K, so K is the final position. So x final is x at point K, and x initial is x at point B. K is at 5 meters, and B is at -4. So I will replace xk by 5 and xb by -4. So 5, we have minus in the formula, xb is -4, so it becomes 5 plus 4, which is 9 meters east. Since the answer was positive, then it is going in the positive direction, which is east. Another way to find the displacement, I will use something similar to this. I will copy those letters without the signs. And then BG, moving from B to G. It was moving in this direction, which is east, which is a positive direction, so I leave it positive. Then from G to D, so it moved this way, so it's going west. Then west is a negative direction, so I put it as a negative displacement. Then from D to K, in a positive direction, so positive displacement. I replace the numbers, 5 minus 3 plus 7, and we get 9 meters east, which is the same answer that we got there. Another example. An object moves from E to H to J to C. The distance will be EH plus HJ plus JC. We add them. From E to H we have 1, 2, 3. We replace by 3. Then from H to J, 1, 2. We replace HJ by 2. Then from J to C, same thing. You count or you check the numbers. 1, 2, 3, 4, 5, 6, 7. We replace by 7. We add them up to get 12 meters for the distance. The displacement, delta x is x final minus x initial. So xc minus x of e, because c is the final position and e is the initial position. We replace xc is -3, there it is, and x of e is -1. So -3 minus -1. So -3 plus 1, we get -2 meters. Since it's negative, then it's going in the negative direction, which is west in this case. Also using the other way to find the displacement, that is similar to this. From E to H, it was moving in a positive direction. H to J was moving in a positive direction. J to C moving in a negative direction. We replace and we get the answer -2 meters west. To validate my answer for the displacement, let's see on the line itself. It moved from E and it ended at C. So started from E, ended at C. E is at -1 and C is at -3. So it moved 1 meter, 2 meters west. So -2 meters west. Okay, so this is how we validate. The displacement is the direct distance from the starting position to the ending position, which is this line. A third example. From E to A to I to E. So the distance is EA plus AI plus IE. We find their values. From E to A it will be 4. Then from A to I will be 8. Then from I to E it is 4 again, so the answer is 16 meters. For the displacement, delta x equals x final minus x initial. It started at E and ended at E. So -1 minus -1, because E is at -1. The answer is 0 meters, means no displacement. What does this indicate? Since it is starting from this point and ending at this point, so the overall is 0 change in position. Same thing if we apply the other formula, delta x equals from E to A, this is E, going to A means moving in the negative direction, so it is negative EA. Then from A to E, so from this point to this point, moving in a positive direction, we put it plus, to I, we put it as positive. Then from I to E, moving in a negative direction, so we put minus, and the answer is 0 meters. If an object moves from A to B to C, so from A to B to C, for the distance it will be AB plus BC. So it is 40 meters plus 30 meters, which is 70 meters. If you want to find the magnitude of the displacement, which means the size or the value of the displacement, okay, from the graph I can tell the straight distance from the starting position, which is A, to the ending position, which is C, is 50 meters. So the displacement has a magnitude of 50 meters. Okay, so this is the displacement.